Yeah, you can probably hear me. Or you will in a few minutes. Yeah. Yeah. We have a few pipes to go through. Cool. Well, I'm going to mute for a couple minutes then. All right, well, we might as well get started, I guess. Yeah, well, we have more people, so. And a dog.
so there's space on the other side, or you can pull in here or something, whatever. If you can see it from there, that's okay. Okay.
Thank you, though.
Yeah. All right. Why don't we start with introductions? That's what we usually
Sure.
do. You first. Like, who are you? Why do you care about Linux?
My name's Garrett Gutley. Love Linux. Been using it forever. That's why I love it.
Okay, forever since like 1932, or
Yeah, like 97, 96.
way near the beginning of Linux. Yeah.
Like when Slackware came on floppies, kind of.
Well, no, in floppies it was. I assure you, it was 1994. But
So it was. That was my very first exposure.
Yeah. Cool. Yeah. So really forever. All right.
Welcome.
What was your name again?
Garrett.
Garrett.
Yeah.
Okay.
I'm Kofi, staff here. Been doing Linux since I've been hanging out here, learning more every day.
Hey, my name's Dean. I've been playing with Red Hat 7.0 since 1997. Love Linux because there is no user license fee.
Yes,
and I can do some amazing things on very little hardware.
I have my own slide, so.
Bob will introduce himself. Tell me about this. Yeah. Okay. Next.
I'm Richard. I started with Slackware.
Started with Slackware. Yeah. Okay.
Zane. I like this because it's more useful.
I'm Lachelle, and been using since Slackware came on floppy disks, 40 of them. I still have one of the original sets. I doubt it's recent.
Wow.
I doubt it's readable, but I've got it. It's so much. Anyway, I use Linux also because it is more useful to me than anything else. Sometimes I explain in great detail why, but
Don Thread. I've been using forever. I think I still got the original Yegdistrel disc, YGG something. Date on it, 1990. That's it, 1994.
oh, awesome! I didn't know that there was one of those. That's right. The Viking software disk. That's the World Tree. It's a.
I never knew how to pronounce it.
I'm not sure I do either, but.
Okay.
My name's Houston. I've been using Linux for like a year. I guess I've been using it as my main OS for like 3 months, but I've been using an SSH terminal for like a year. And I like it just because it's better for programming. And I'm a computer science student at the university.
Oh yeah, computer science too. That'd be cool.
Hi, Raj. Got into Linux because I wanted to learn the main operating systems, just so I could put it on my resume and say, hey, I know this. Also got into it because the same reason, SSHing for school and classes, but also messing around with Raspberry Pis and cracking it. I'm Andy. I've been using Linux since about 1997. My first distro was Mandrake.
Oh my God! Yeah.
Nice.
Because I'm not a keyboard user. So,
It was.
comparatively.
Yeah. Yes.
Hi, I'm Sam. I started using Linux like really recently, and I find that it's a lot more efficient than Windows.
Yes.
Hi there. I've been using Linux for about a year now. I'm a CS student, so I've been using it through there. I was introduced to it by this robotics club where we use that for operating system for the robot.
All right. I think that's everybody. All right. Well, I'm happy to be your presenter this evening. I'll go to the About Me slide. I'm Bob Belknap. I've been using Linux for about 15 years, 16 or so. I think I round to 5 years because 17 is a weird thing to say, but I have been a systems administrator, more or less, for most of that time. I got started with Linux in college. I was actually an English major, a computer science minor, and I got involved in the Free Software and Linux Club at my university, which is at Utah State. after I graduated, I was unemployed for a while, and I hung out on IRC with a bunch of the people from the club and learned most of what I knew about Linux from them. So I think that user groups are important, and community is important, because that is largely what taught me what I know. So after that, I went on and got a tech support job at a web hosting company and moved up to system administrator there, and moved on to a larger Fortune 500 company that I was at for the last 7 years or so. And last year I moved from Utah out here, and I work at the university for a pathogen database website that is run out of several universities. So that's me. All right. SSH. Everybody here have an idea of what it is? I'm trying to get a gauge of what sort of experience levels there are. I heard most of you mention it.
Does anyone not know what SSH is? Please say it, but everybody knows.
All right.
There's gonna be a quiz later.
Yeah.
There won't be a quiz, but if you don't know, don't be ashamed. Just tell us.
Yeah. So the most common sort of usage that people use it for is connect to remote machines and run stuff on them in a shell. You can get it anywhere. It is everywhere. I don't think you could find a Linux distribution that doesn't include it. If you're on Windows, you can use PuTTY. Mac is basically FreeBSD, so it has SSH clients included. SSH servers, any distro will have them. Most will not have them running when you start, or at least most of the end user focused ones like Ubuntu. Yeah, it's everywhere. So I'm just going to start out with a few basic stuff, and we'll see what happens. So you connect to another machine. You say SSH to that host. You can specify your user as user at or with a command line parameter if you want. You can also specify remote ports if you want. SSH runs on port 22, and everybody knows it, so if you want to make your SSH server slightly harder to find, you can run your SSH server on a different port. Yeah, it's not...
Slightly more secure. I mean, port scanning is pretty common, so...
It's slightly less noisy for your logs.
Yeah, but...
It is not, like you say, not technically more secure. It's obfuscated a bit. So...
It keeps your friends honest more than it keeps the actual pros out.
Yeah. And there are tools. Fail to ban is great for banning people that are port scanning you and trying to guess your passwords. But I'm just mentioning that it's an option here you can have. You can also specify remote commands, and you can pipe stuff through SSH, and you can run tar through it, but just use rsync because I'm sure there's use cases for using tar through SSH, but I'm going to be hard-pressed to say what they are. So I'm going to use a little demo setup here. I have 3 machines called Earth, Mars, and Jupiter, and we're going to be connecting between them in various ways. So if I were to connect to Mars, say, and run hostname, we can say, hey, my hostname is Mars. We could say this is stuff, and we can pipe that to Mars and run, get that input into temp stuff, and it can do that, and we can then run something like that. So You can take input on one machine, pipe it through SSH, and run a command on the other end that takes that input and does whatever you want with it. This is the simplistic example, but you can find all sorts of uses for that. Yo. Hmm? That's coming up. I actually should have taken these keys out of here so that I would build up to that, but oh well. All right. Providing options. So there's command line flags, which we've talked a little bit about. There's various config files. In kind of a Unix tradition, there's global and local configs. You have your global stuff in the etc or the etc directory if you're one of those types. The stuff in etc, I'm gonna be etc tonight, I guess. The stuff in etc is gonna be global. You got SSH config and SSH config, and those handle global options for SSH and SSHD respectively. You have your users SSH config in the .ssh directory, and we're going to talk about this a bit later as well. Here, hang on, I'm going to do one other thing over here. Okay. There's also options that you can specify. I say here command line flags specifying config options, which is kind of confusing, but I'll show you what I mean. So if you look at the man page for SSH and you look here, man, this is a small screen. That's going to be kind of tricky to read there. Anyhow, there's all these config options you can give to SSH, but you can specify them on the command line with the -o option. So if you were to put those in a config file, you would use them here. If you were to put them in the command line, you would use them with the -o. So for example, if I wanted to say pass the strict host key, no checking, I think that's it, option, there we go. So that's another way you can pass commands into SSH. It's actually pretty handy because there's almost any config file option you can have on the command line if you're sticking stuff in scripts and whatnot. Alright, so we're going to change the port on Mars here. So let me just check this out. In our completely unintelligible blue text here.
Actually, it looks good on the stream.
All right.
Well, I can read it fine here, but anyway, that looks better.
So,
Yeah,
you're not supposed to see the comments anyway, right?
I'm going to try to notice that thing.
Can you just turn the syntax highlighting on?
Yeah, I'll just move on. Yeah, it'll be fine. The point is that I just changed the option here from 22 to 2200. Seems like a decent enough port. Thank you, systemctl, for not telling me that you actually did it. Anyhow, we'll assume that has been done. So now if we go to Mars, hey, we can't connect. But we can go into our local config and say, For the host Mars, let's say that its port is at 2200. Now, conveniently, we can still go and SSH to Mars. Now, we have this warning here, which is the host key warning. I'm going to say no for a moment. And do my other example here. Where did my example go? Maybe I, what was it? Oh, it didn't. I gotcha. Alright, so if we're on Earth and we say we don't want to check the host keys, we go to Mars, then it doesn't complain. We're going to talk about keys in a minute. So, of course, you can also say, and that'll work the same. But of course, it is very handy to put this stuff in config, because then you don't have to worry about it. Oh. Sneak preview, let's ignore that. And then curse my tiny laptop keyboard. Alright. By the way, if anybody has any questions about anything or concerns or comments, feel free to pipe up. I don't mind. Alright, so your local config file is great. I will mention that as I put in here, you can, oh, I did that on Mars. That was my problem. We'll just forget this for a moment and pretend it's not there. Look, poof. You can say, use globbing here. You can say, any host, I want to say forward agent, yes. Or I want any host to be port 2200. Then you can refine that and say, but I want this other host, Mars, to be, when I log in, I want the user to be Bob. So, if we try connecting to Mars this way, behind the scenes it's trying to connect as the Bob user, and it's getting denied. If I
Specific thing in that file.
Right.
It doesn't do a top down. First one that hits the criteria. It just goes.
Is it just like go down the list or
I believe it's order based.
so if you put the star after the Bob,
Right. So
or if you said user,
I'm asking for that. No.
Mm. You're trying to catch me?
No,
No.
not at all.
I'm not sure. I've never had an occasion where it conflicts. Yeah, but I think it's top down. We can do a quick test and see.
so if you said host Mars above that user or something else, there it would have to be user, right? So host Mars. So if you said host star user Ubuntu and then host Mars user Bob.
Yeah, there you
go. Okay, something like this.
Yeah, and see which one it tries. If it picks Bob, then it's just picking the first one on the list. And if it's picking, yeah, that's right. Yeah, so it's picking Bob. I think if you move Bob down underneath Ubuntu, maybe then it would.
Well, that's how it was before.
Yeah, well, it wasn't, but the user Ubuntu wasn't in there before, so that was the only user statement. So
Yeah.
that's the first one. Okay. Easy.
Problem solved. But you can get lots of great stuff in here. We'll go back there. Alright. So, SSH keys. They're fantastic. You'll learn to love them. They come in two pieces. They're public-private key pairs. The public one you don't have to keep secret. The private one you do. The public one you can give out. You can make it public. And you can allow users in to your systems by that public key. So I'm not going to get into the cryptography of it, but if you have the public key, you can prove that somebody has the private key. So you put the public key on the server, and your client connects to the server, and there's some cryptographic challenges that go back and forth, and you prove that you have the private key, and it says, all right, great, you can come in. And it's very strong and very useful. You also have to protect your private key because it is just a file, and if somebody stole that file, they could then access all of the servers that you have your public key on and do stuff as you. So that's not very good. You store it on your machine. So let's make some keys. This is what we want to do. There's some options you can give to it. The type of key, the size of the key you want. Some places want a larger key than others, depending. You do want a passphrase, but you don't have to. So let's make this key pair here. You can also specify a file. It defaults to ID RSA. So let's go for that. I want a passphrase. The great thing about this is you can put in something very long. You can have spaces. You can have all kinds of stuff in your passphrase. It's not a password, so you can get your passphrase very secure. And you can think of this passphrase on your private key as kind of like a secure wrapper for it. So people can't use, if somebody steals your file, they can't unwrap that package without the passphrase that you put in when you created it. And then without unwrapping it, they can't use the key to get in to any of your servers. So this is a good thing to do with your keys. However, if you you might be wondering that you still have to enter your passphrase to use it, so you haven't gained much. Let me get this key. Well, I'll talk about a couple other things. If you want to add your key, your public key to a server, you can say copy ID. Let's copy this ID. I think that I is the R here. We'll find out. To Mars. All right. So I already had a key on there, so it didn't ask for my password. But if you are copying your key to a new server that you don't have a key on. First, it will ask you for your password and let you enter that key. So let's see if we can log in with that key to Mars. You can specify what key with I command. Hooray, we did. So, yep. So in the .ssh directory here, we got a few files. One of those is authorized key file, which looks a lot bigger on this tiny display than it actually is. There's just 2 lines in this file because there's two keys in there. This is the one that we just added. The authorized keys file controls what keys you are allowing into your machine. So if you're running a machine with 50 users, you have them all generate their own keys, give you the private keys. You can all give them access to that server. If you want to disallow access, you can remove their key and they can't have access to that account anymore. It is very useful. So, now hang on a minute. I missed something. Alright, this is what was supposed to happen. It used my other key. Anyway, yeah. Getting a little bit ahead of myself there. So, connecting to this key, it wants the password, and I type in that whole thing. As you may have guessed, there are some shortcuts around using that. And yeah, well, I'm going to talk a bit more about the host keys. So when you first connect to a machine, you'll store the host key of the machine in a file called known hosts. So when you connect to the SSH server, it also has a key that it presents to confirm its identity to you. Because if somebody were to hijack DNS and say, change where Mars, the IP that Mars points to, you could connect to a different machine. So basically you want to make sure that Mars really is Mars. And to ensure that, when you first connect to a host, the server says, hey, here's my host key, hang on to it. And you can actually verify the fingerprint. If you're very secure, you could walk over to your administrator and say, hey, what's the host key fingerprint for Mars? And they say, it's this, and you can verify that that is actually Mars. And you say, yeah, add it to my keys file. And we're not going to put in the passphrase again. So now if you look in known hosts, you're going to have the host key for Mars. Back in the old days, you'd actually be able to see what the host name is and what the host key is. More modern distributions have started hashing the host name, and that is kind of useful because it obfuscates what hosts you connect to. So if an attacker compromises your account, probably the first place they're going to look is in the known host file to see what other hosts you regularly connect to, and if they have your key or password, they can start going through and connecting to those hosts and worming their way into your network. So it is good to verify those host keys and keep them up to date. If a host key changes, you get one of the best error messages ever. I'll demonstrate that in a minute. The host keys are in etc SSH, by the way. If we get rid of them and we restart SSHD, it will regenerate them. Yes. No. Did I miss something? Oh, great. Well, I just killed Mars. Okay, one moment. So, that's something you shouldn't do, by the way, is kill your SSH server. Or, you know, at least make sure you have access to it.
These are Docker containers.
No, they're not. They're actually AWS machines. So I'm gonna reboot that guy. Anyhow, I kind of jumbled my way through that. Anybody have any questions about any of that?
What is exactly the difference between a private and how do they use identifiers?
Okay. So let me see if I can get all of my encryption information wrong. I believe you could think of it like if you have the public key, you can encrypt a message that can be decrypted by the private key. If you have the private key, you can decrypt messages made by the public or private key.
Only the one holder of the private key can decrypt it. So you can encrypt a message to Alice using her public key. No one else in the world can decrypt it, or unless they have her private key. Only the holder of the private key can decrypt it. So even the person who encrypted it can't decrypt it necessarily.
Yeah. So the SSH server can take your public key, encrypt a message, send it back down to SSH, where your client can say, I'm going to use my private key to decrypt this, and send the response back to the SSH server. Yeah. And that is how they verify that they actually have their
So the keys have more to do with encryption between machines rather than like access.
both.
Both. Okay.
It uses the encryption for the verify.
Yeah. So there's authentication and encryption.
So if I wanted to get onto your SSH server, like let's say I wanted to get on Mars, and I know you're like locally running it, but like let's say I wanted to and you had a text that I could, what would I need to do that? Just the public key?
Yep, you just send me the public key. Okay. You always keep your private key private.
So I would send you the public key and you would like make me an authorized user and then I can get on.
Yep. I would create you a user and then add that key to your authorized keys file. And then you would be able to get in.
Add the authorized key to his key files
On his machine, on the
Yeah.
server.
On the server.
His account on the server.
So
Yep.
I'll send my public key to him. He'll make a user file for me that has some information about me and stuff like that. And then inside of it, I have which key was in my user file.
Well, your local user will have your private key.
Yeah, and so the public key is in
server will let you log on.
Yep.
From home box.
If you send your private key in the email to your administrator, they will say, go back and regenerate new keys. Because you've just compromised your private key. Or at least they should.
If my private key is compromised, can anyone get onto my?
Anyone that has the key,
They can masquerade as you.
yeah.
And so the SSH, by the way, the files where the keys are stored, SSH will just refuse to work if they don't have at least a minimum security conditions. Just every user has and they're separate machines. Machine that made the capabilities go. Yeah, it only anyone who puts your public key on their server.
So they authorize your public key. So
Yes.
then when you connect, it's sending your public key whenever you connect.
Yeah, when you connect, you say I want to connect this public key, and the server from the public key it can ask questions that only your private key can answer, and so that only.
So the public key helps make encryptions that only the private key can make.
Yeah. It's for both encryption and for authentication.
All right.
And there is a try to there is a
Does that clear up your question? Thanks for fielding it, by the way, Michelle, while I'm messing with this machine.
I recently made a presentation about public and private key out. I was prized for that.
Yeah. Yeah, I'm trying to resurrect Mars here. 1 second. Anyone else have any questions or concerns? No? I am. I am. Yeah, but it's really unfortunate that I killed this guy.
So are you just getting a terminal on AWS?
Yeah, that's what I'm looking at. But I really don't have time. Yeah.
Mark, there's a chat for you. Do you see it from Mark?
Oh yeah.
If you can console it, if you can get a terminal, dpkg-reconfigure space SSH.
I see. Well, thanks, Mark. I should have done that before I disconnected like a dope.
I kind of thought that, but I was trusting you.
Yeah, well, now you've learned a valuable lesson about trust. Yeah. All right. Well, I'm just gonna kill him. No, I don't want to kill Mars. All right. Well, maybe we'll just go on half a solar system. Well, now I only have 2 planets. All right. Well, we'll muddle through. All right. So, yeah, keys. Poor Mars, rest in peace. So SSH keygen can also look for hosts in the known host file that are hashed. Did I not get that right? The F is optional. I'm trying to parse this. It's like,
The problem is the projector is kind of low resolution. So
yeah.
it's having to up everything down. That's why it's small.
Well, oh, right. That's not what I want. I actually want the F. Sorry, folks. No, that is not what I want. Nobody's correcting me. Yeah, I'm trying to find the key in here. Here, I'll look at a decent terminal and figure it out. Oh, right. All right, well, I thought Mars was in there, so I guess it is F. Right, let's just take care of this. Yeah. I'm a little slow. All right, well, so anyway, the point of this rambling thing here is that you can use the F flag to keygen to figure out if a host is in your known host file. Since it's hashed, you can't just look at it directly, so you can use F to do that. You can also use R to remove it. And it is, yeah. All right. All right, SSH agents. So, you probably noticed me connecting to a couple of machines without putting in a password or anything. That is done by the magic of an SSH agent. So, what an SSH agent does is it holds your unencrypted key in memory on the machine, and then you can access that, SSH can access that unencrypted key. So what this means is you only have to enter your passphrase once per session, and then from then on you can just connect seamlessly. So when you run SSH agent, it does a few things. It runs, goes in the background, and it prints out some variables. So it prints out where its socket is, its socket file is, and it exports that variable, also its PID, and it echoes that PID and does all this stuff. So this thing is actually running. At the PID that it says. You can also run a shell. You can say SSH agent bash, and it will export all of this stuff inside of that shell. Which is a different one. And SSH uses these variables to connect to it and know what it is. You can also, if you like, let's do is that not what it is? I never use it. Well, yeah, but it didn't.
Try echoing it to see if it's even set.
Well, it should. Well, maybe not. Anyhow, the typical way you'd want to use it is to do this. So what this will do is it will stick all of those things that it spat out before into your own environment. So you now have those running, those environment variables in your environment. Most distributions that you'll run across will have SSH agent running as part of the user environment or something similar. So if you just fire up your stock Ubuntu, you're probably going to have an agent running, and it will probably automatically pop up a dialog box to have you enter the passphrase for your key if you needed to. But otherwise, if you don't have that, you can interact with it on the command line just fine. So what you'd want to do for that is use SSH add. So you give it an L flag, and you can see that it has no identities loaded. You give it a key file like the one we, the one we generated a while ago, and we say add that to the agent, and that adds it to the agent, and now it will list that key as part of the agent. So what's happening here is that the SSH agent process is running, and it has your unencrypted key in its memory, and you can communicate it through this sock file, which is the SSH auth sock right there. It's randomly named so that people don't guess where it is, but that's the guy right there. And that's what you use to communicate to the agent. That's what SSH uses to communicate to the agent. So if Mars were up right now, we would connect to Mars without that. So right now, our key is not on Jupiter. because I don't have my other key. So let's take a look in temp here. No. You'll see there's a couple things in there because I was running a couple SSH agents. So I'm actually going to do something here. Hang on. You can set your authsock to one of these agents and use that agent. No. Did I? Okay. So where did this key come from? We never added that. We'll get back to that. Let's go back to our copy ID and copy this guy over to Jupiter. All right. Jupiter's the new Mars. So, what just happened there? Anyone? I don't have my other agent. Let's go back to this guy. All right. So what I was doing there is changing the value of the SSH authsock environment variable to point to different files that go to different agents. So what we're running now is the agent that we started with and we loaded our key that we created into. And SSH add shows us that we have that key. So we should be able to get to Jupiter with that key just fine. Some of what I wanted to illustrate there is something called key forwarding, or agent forwarding, which is something that you can do that's very useful. If you're running an agent and you connect to one machine, with that agent, you can say forward my agent over to that next machine. And then you can connect from that machine anywhere else your private key will let you into. That makes sense at all? And how it works is the remote machine that you connect to creates another socket file that will communicate through SSH back to the agent running on your local machine. So up here there are these socket files, and this guy is connected through SSH to the agent that's running on my laptop here that has a key loaded that will access all of these. It's the key that I gave to AWS to provision these. And since I'm connected to Earth through SSH, it will forward that agent through there. This is very handy if you're in a place that has a jump host or a bastion host, you can forward your agent from your local machine to that bastion host and then connect wherever else. Or if you're jumping through machines, you don't have to run an agent on every machine. You can just forward your agent connection through to all the others. But you have to be careful, because if you are jumping through untrusted hosts, like I just showed, somebody that has root on that machine could hijack your agent that you forwarded and connect as you to somewhere else. You just have to export the environment variable. If you're root, you can look in the temp directory and see everybody's agent sockets in there, and you just say use that one, and if
That's it.
then you have access to their agent. Yeah. So forward your agent through trusted hosts. I think I have something like that. The other thing, you can load multiple keys into an agent, which is pretty useful. So you can run one agent on your local machine and load like 5 keys into it that you use to connect to a bunch of different services. And then you can just go no password SSH connections wherever you go. However, you will run into a problem at some point if you start loading too many, because SSH actually tries all of the identities in turn. If you have like 5 or 6 of them and you connect to a server, it will say, will this one let me in? Will this one let me in? Will this one let me in? And then the server says, hey, you've tried 3 times and failed, buddy. Like, too many authentication failure attempts, and it'll boot you out. So, something to be aware of. All right. Port forward and tunneling. I'm going to totally run out of time, but I'll get as far as I can. This link goes to a guide that is really pretty well. I'll share these slides later on. He has pictures and everything that make this super easy to understand. All right. So, port forwarding, best thing ever. So, SSH can create encrypted connections through SSH, and you can connect these 2 ports on either side of your SSH connection. So this means that you can ferry connections through SSH. You can do that securely, and it is super useful. So, for example here, this is going to use Mars, but Mars is dead. So each one of these machines has a web server running on it. And I'm just going to use HTTP connections because it's useful. Each one of those just returns who they are. Mars actually is still up, so look at that. It's just inaccessible. So each of those are there. Let's pretend that they're not, though. And say we're on Earth and we need to connect to a web server on Mars. Or let's say Jupiter, because Mars is dead. So we'll say 8080. We run this command, which I'll tell you what it does in a minute. To Jupiter. We say we don't actually want a connection. We don't actually want a TTY. And we're going to background that. All right. So now we can do connection to localhost 8080 and see that we're actually connecting to Jupiter. So this bears some explanation, and it can get confusing because there's a couple ways to do this. So what this is saying is we want to make a local forward, and we're going to connect to Jupiter, and we're going to say we're going to create a tunnel. The input side of that tunnel is going to be on port 8080. The output side of that tunnel is going to be on the remote side at connect to localhost 80. So this is saying connect to Jupyter, set up a forward on port 8080 of my local machine, and connect it to port 80 on localhost on the remote side, which is Jupyter. Does this make any sense to anyone? Yeah? No?
Yeah, I've done stuff like that before, and it's when you read it to yourself, you almost have to jump around on it.
Yeah, so it's kind of weird, and it's kind of confusing. Yeah. All right, so you can think of it like this. You have two hosts involved in this tunnel. The one you are on and the remote one. In this case, Earth is at one end of the tunnel, and Jupyter is at the other end of the tunnel. So because these tunnels are, you can think of them as pipes, but they're one-directional pipes because you have to connect to one end and come out the other end. So we know from here that the two ends of the pipe are going to be on Earth and Jupyter. The rest of these arguments tell what direction and where to hook those pipes to. The first part is always going to be where the input side of the pipe is, what port the inside side of the pipe is. And the second part is going to be the host and port of where the output side of the pipe is going to be.
There's local on Jupyter.
Yep. This local host is relative to Jupyter.
Sometimes you have to put in an IP address. I found sometimes localhost is too ambiguous. You get more than one localhost with IPv4 and IPv6. I've had to actually put in. I had to use it too.
So this is very useful if you are running, like, say, a development web server on localhost and it's on a remote host. You can SSH to it and say, give me a tunnel running on my localhost 8080 and connect it to that machine.
Or if you want to get something through a firewall, they want to block your favorite site. If you have a machine outside that can't get to the site, SSH to that machine, go get this site through that machine, bypass the firewall.
Yeah.
Well, this is why.
So I might be jumping ahead of myself. All of these examples use Mars, and so we're just going to reverse all of the hosts in here. So in this example, we are saying, okay, connect to Jupyter, and then set me up a pipe that's going to be on 8080, but connect the other end of the pipe to port 80 on Mars, but connect it through Jupyter. So now we connect to 8080 and we see that it's Mars. If we looked at the web logs on Mars, we would see that connection coming from Jupyter. Yeah.
I thought it was Earth.
Right. Yeah, that's where it gets confusing for sure. But it's very common to use it that way because generally you want to get a port on the machine you're connecting to back to you. And so you use localhost a lot.
22 most times. The SSH one.
Like right now, like what,
Yeah, so
so we're going from Earth to Jupyter to Mars, right?
Yeah.
Yep.
And what ports are you running through the middle?
Yeah, so SSH is handling the connection to Jupyter, so that's going to be through 22. And that's going to be encrypted. From there, it's no longer encrypted, and Jupiter's just connecting to port 80 on Mars.
Jupiter is just connecting to port 80 on Mars, and it's whatever comes back from Mars, it's putting it into through the port 22 tunnel and going back to your machine. And
Yep.
coming out the other side of port 22, and then going up and getting exported out. Yes, it is, but that's how you get the website and your firewall plots.
Yeah.
Yep. All right. So, yeah, this kind of assumes a lot of knowledge about how ports and stuff work, but that's fine. So, reverse tunnels, they are the same, except they change where the input side of the tunnel is. So, see if we can follow along here. So I'm going to do a reverse tunnel. And those are just going to be confusing. The host names are all wrong now. So I'm going to connect to Jupiter, and I'm going to have the output of the tunnel be the same, go to Mars, port 80, except because this is a reverse tunnel, I want the input side of the tunnel to be remote. So this is going to mean that Jupiter will be listening for 8080 and connecting to Mars. So we connect to Jupiter and we do and 8080 and we see Mars. Confusing? So this is like the local forwarding. You can think of it like the local forwarding. The only thing that has changed is where the end of the tunnel is. Yeah. And this is kind of a contrived example because you don't really gain anything by doing this so much, but there are valid use cases for doing this. Basically, you're saying connect to Jupiter, and on that side, set up a tunnel localhost through to 80. I mean, in this case, in this little story, Jupiter can already access Mars, but best thing ever. I think that's the third time I've said that. Yeah. We won't get through everything, but oh well. Dynamic forwarding. So, D. If there's anything you can remember is the usefulness of the D flagged SSH. I'll say this. What this does is it sets up a SOCKS proxy on port 80 of your host, which here is Earth, and connects to the other end through Jupiter. So that means that you can say did I get that? Now, by the way, ifconfig.co is a great service. It will return you the IP address that you're requesting from. So it is basically asking the outside world, hey, where am I coming from? What's my IP, essentially? So if we go through the proxy here, we'll see that the IP is not the same as the IP that we are not because we're using Jupyter as a proxy. So what's nice about this is that you can go to any web browser and say, I want my proxy to be localhost 8080. You set up an SSH tunnel directly there, and then all of your traffic goes through SSH and out of your remote end. And then you're essentially browsing the web from your remote host. And you have your own little VPN. So you can set up VPS or an AWS account somewhere and use SSH to proxy to it, and then browse the web through whatever, which is how you can get away with watching videos that are restricted for viewership in the US by connecting to a machine in the UK and making a proxy through there. And you can. There's a functional limit. I mean, you add latency at every hop. And there's a management limit, I suppose.
So most of the functional uses for this would just be getting around firewalls and
Yep.
location restrictions.
Yep. If you can SSH to it, you can generally work your way through any sort of firewall, which is nice. Bonus problem we're not going to have time for, but you can forward the proxy port. So you can go multiple hops out there. You can set up a proxy on one host and then forward that proxy port out to another host and then connect through there. But we don't got time for bonuses. Forwards can be specified in your SSH config file, which is pretty useful. You can not do here. Let's change this to Jupyter. Not have this and say forward ports. I think this is right. I'm going to be amazed if I got that right. Yeah, what is it? Time to.
It can't happen. We should go and look up the man page.
Yeah, I was going to look at the man page behind the scenes.
Yes.
Are you saying that we're out of time? Yeah. So, yeah, you can do that. Take my word. There's a lot more that we won't get to, but you can look it up. You can do, I'm just going to mention this briefly, you can do SSH multiplexing with this control master setting, which will route all of your SSH connections through a single connection. So you can connect multiple SSH connections through a single connection. That gets you out of a lot of problems of setting up a TCP connection for every connection. So if you have some process that SSHs like 5 times to a remote server in like a minute or a couple seconds, rather than setting up a TCP connection every time, you can set up control master so that it goes over the same SSH established TCP connection. This is useful if you're a lot of source control stuff that goes over SSH like Git that will authenticate several times. You incur some latency for each one of those connection creations, and you can multiplex that with control master. And there's ways you can control that and everything. Yes, you can forward X connections. Yeah. I will mention this really briefly because it's really esoteric and weird and kind of cool. You can control the connections with this ~c. Don't tell me what to do. Hey, there's an SSH prompt here, and you can give commands dynamically to the existing SSH connection. It's meant to be used at a terminal prompt that is empty, and it's just ~c. So that will give you the prompt. There's various things you can do with it. Tilde question mark will tell you what those are. These escape sequences. You can disconnect, you can open the command line, you can rekey the connection if you're into that. You can increase and decrease the verbosity, which is pretty nice, and suspend it or see what connections you have forwarded in there. So here it shows what those connections are. If we were doing any port forwarding, they would show up there, which is handy. You can set the verbosity level down. Let's make it debug. Yeah, right. I didn't fix that, did I? Oh, maybe not for that connection. Anyhow, we're out of time. I probably ignored any YouTube comments, so sorry, you people that are there, which is Mark.
I'm watching according to. By the way, we have our website, the CHUGALUG website, is on GitHub, and so usually I just post these things to the CHUGALUG website. You can also just support the repo on GitHub and get whatever presentations are posted.
So yeah, we'll there's some other links in here. There's a bunch of great stuff that uses SSH. SSHFS I will mention as well, which lets you mount the remote file system through SSH, like an NFS mount, and then you can browse through it locally, which is handy for a lot of things. Ansible and Fabric both use SSH to do remote orchestration stuff. Shuttle is a bit more advanced of a proxy thing. It actually will write IP tables and rules to dynamically redirect network traffic from your host to various systems that you connect to through it with SSH. It's pretty useful, and so there you go. Yeah, thank you. And thanks Mark on YouTube for the advice.